Hey chemistry kiddos, I am sorry that I cannot be with you today, but I hope that this video will help you figure out everything that you need before next class. You should have plenty of work time today, so we will check in at the start of next class by going over homework, and yeah, it'll be great. So from up front, you should have been able to grab this worksheet. I also attached in the email the key to the homework today on Intro to Acids and Bases, so please go through that on your own, and we're just gonna assume that everyone did their homework today. So let's go ahead and start talking about next class. So next class, you're gonna be completing a titration. So today we're just getting a little bit of an introduction to that. So as you might have noticed from your homework, water is special, and water's special because sometimes it acted like an acid and sometimes it acted like a base in our reactions. And so since water can act as both things, it's what we call an amphoteric substance. Now, we're not always going to be mixing an acid with water or a base with water, so sometimes we mix them together. And this is called a neutralization reaction when you mix an acid and a base. And the reason for that is that if you have something with a high pH and you mix it with something with a low pH, you get a pH that's neutral or right in the middle. So we say that a neutralization reaction occurs when an acid and base are reacted together, and all of these reactions are going to produce water and they're going to produce a salt. Now, these salts are just ionic compounds, right? So we're gonna make water and we're gonna make an ionic compound. Now, the example that we're gonna look at for this is actually what you're gonna be doing next class, which is where you're looking at hydrochloric acid and you are mixing that with sodium hydroxide, which means that our products over here are going to be water, H2O, and we're going to form a salt. Now that salt, if we look, it's going to be sodium and chlorine. So we get sodium chloride, NaCl. Think about this for a second. Sodium chloride, we should be pretty familiar with. It's table salt. Water, also pretty familiar with. Are either of those things harmful? You should be saying no, which means that if we do our reaction correctly next class, you should be able to dump these things down the drain, right? That's going to be our goal. If you don't do it correctly, please don't dump it down the drain and call me over to make sure that we're okay. Okay, so titrations. These neutralization reactions help us do what we call a titration. So the reason that we would do a titration is if we're trying to figure out the concentration of something that we are unaware of. So if we don't know the concentration of something, we can use a titration to do that. So titration involves the delivery of a measured volume of a solution of known concentration into the solution being analyzed. So if we have a solution that we are unaware of its concentration, we can add in whatever the other thing is, add a known concentration in order to figure out what the other one's concentration is. And we'll actually do a practice problem today. So the titrant is the volume of solution of your known concentration. And the analyte is the solution that's being analyzed. Now, we have a special point that's called the equivalence point, and it is the point where all of your analyte has been reacted with, which would be this point where we only have water and that salt present. So we can look at an actual titration curve here. You do not have to make a graph next class. You're not going to be making a titration curve. But what happens is you measure the volume of solution with the known concentration in order to analyze the unknown. Right? So you're slowly going to be adding in a volume, a little bit at a time, to figure out when you reach this equivalence point. Now, the equivalence point is special because this is where your moles of acid is going to be equal to your moles of base. Right, so we're bringing moles back into this. This is how this is going to help you do the actual math of this. And this is also important because you have to pick an indicator that you're going to be using. And this is the point where the color change of that indicator is going to occur permanently. Right, you might see a little change occur, but then if it goes back to what it was before, that means that we haven't fully reached that endpoint. Now, here we see that our equivalence point is at a pH of 7. That makes sense in terms of it being like a neutral value, but it's not always there. Depending on the strength of your acids and bases, which we're not really going to get into in this unit, sometimes it can be higher than pH of 7 or lower. But it is, your titration curves always look like this, and so this is always going to be in the middle near your vertical part of the graph. Right, so wherever you get this up and down portion, the middle of that is going to be your equivalence point. Okay, so hopefully you also made sure to grab this titration and dimensional analysis homework. So on the front, you're going to be plotting some points in order to make your own titration curve, and then you're going to answer a couple questions about it. But let's look at the back for a second so that we can actually go through one of these sample problems. So as I was saying, at your equivalence point, your moles of acid is going to be equal to your moles of base. Moles of acid is equal to those moles of base. So one thing that's important is we're going to be assuming that our concentration or molarity of our acids and bases is always going to be equal to the concentration of hydroxide or those hydrogen ions, right? So for example, if you have 0.5 molar hydrochloric acid, there's a hydrogen in there, so we're going to assume our concentration of hydrogen is also 0.5 molar. So in this case, if we have sodium hydroxide, and that is a 2 molar solution, that means we're going to assume our concentration of hydroxide ions is also equal to 2 molar. So here's the problem that we're looking at, and we're going to do this one together. So it is asking you to determine the volume of a 0.1 molar sodium hydroxide needed to titrate 50 milliliters of 0.2 molar nitric acid. So the first thing that you want to do is identify what you're given. We're given 2 values about our acid, and we're given 1 value about our base, and we need to find the other base value, okay? Now, the first thing that you're going to want to do is you need to write an equation for this reaction. So HNO3, nitric acid, is your acid. You're going to add that to your base of sodium hydroxide. Now, if you're mixing an acid and base, it's a neutralization reaction, which means we're going to form water and a salt. So, water and that salt is going to be sodium nitrate, NaNO3. Now, make sure that you form a neutral ionic compound, right? You need to make sure. So now we can look back and we balance this. This is a 1, 1, 1, 1, so we don't have to add any coefficients, but it would be important if you did. Now, we talked about this back in the solutions unit, but these are molarity values. Are we able to start with molarity values in our dimensional analysis? The answer is no, which means we're going to start with this 50 milliliter value of our nitric acid. And the first thing that we want to do, right, we can't really work with milliliters, so we're going to convert that into liters. Okay, now we're in units of liters, and we can get to moles, right, because we're trying to get to this point where our moles of acid is equal to our moles of base. So we can use our molarity of 0.2 moles of nitric acid for every 1 liter. And now that we're in moles, we can use our molar ratio, right? So 1 mole of nitric acid is equal to 1 mole of sodium hydroxide. And then since we're trying to get to a volume, we can use the molarity of our sodium hydroxide. So we have 0.1 moles of sodium hydroxide for every 1 liter. Now, you can stop here and give your answer in liters, or you could convert to milliliters. Doesn't really matter. But we're going to plug this into a calculator, and when you do, you should find that it takes 0.1 liter of sodium hydroxide in order to titrate. Now, what is your homework? You have to do this graph on the front. You have to do 2 of these practice problems. The third one is an optional challenge problem, right? That means that you do not have to complete it. The rest of your class time, and you should have lots of it, like almost an hour and a half, should be spent on doing this worksheet and getting your pre-lab prepped for next class. Please, please, please be prepared for lab. You need to be prepared for lab. If I am not confident in your ability to know what you are doing next class, I will not give you chemicals. You need to figure that out before I'm willing to let you actually do the lab. If that requires you to come in during additional tutorial time, that is a you problem, right? I will not be helping you if you do not know what you're doing, okay? So please be prepared for lab next time. Feel free to grab your lab notebooks if they are still in the drawer in class, and I wish you luck. I will leave extra copies of the lab up front in case you need another one of those. I will see you all on Tuesday, and I hope you have a great weekend.